these are the notes on structure and properties of bonds. And you should have watched the video discussing just what are the properties of different types of bonds. Now we're going to look at how we can talk about the structure of those types of bonds and make conclusions based on those and kind of doing some CERs. So when we are looking at these, we want to focus on what's happening with our electrons in bonds. It's the electrons that are sharing or being transferred. And so if we can look at what specifically is happening with our electrons, that's going to help us understand why things are happening. So ionic bonds are electrostatic attractions between cations, so between positive ions and negative ions, that result from that transfer of electrons. So those positive and negative ions attract each other because of Coulombic force, that force between opposite charges. We previously looked at this in an atom. We talked about, oh, if this is my nucleus and these are my protons, how is it attracting my valence electrons? So we were looking at Coulombic force between those. Now we're going to look at that Coulombic force between different atoms. So what is the Coulombic force between a sodium ion with a +1 and the chlorine? And because we have those different ions, our ions are locked in a crystal lattice structure when they're in a solid state for ionic compounds. And this structure requires a lot of energy in the form of heat in order to separate those oppositely charged ions because of that high Coulombic force, that strong Coulombic force holding those ions together. And so that results in a high melting point. And so discussing the structure and how that leads to these different properties. In metallic bonds, we have that sea of electrons where, again, all of our valence electrons are being shared by those other surrounding metals. And so valence electrons are shared. That means that that sea of electrons, those electrons can move freely. And then electrons in our bonds for covalent. Those covalent bonds are forming between nonmetals, which share valence electrons, which means that no ions are formed because we have no electrons being transferred. They are only being shared like that. So we have electrons transferred, forming ions in ionic compounds. We have sea of electrons being shared in metallic compounds. And in covalent compounds, we have individual electrons being shared with another element to form a bond. And so how do these electrons impact the properties of bonds? So if we consider the electrons in an ionic bond, and then we're going to answer the question. So water molecules have a side that is more negatively charged due to the high electronegativity of oxygen, and a side with a positive charge due to a low electronegativity of hydrogen. How will an ionic bond mix with water to dissolve? So we want to look at this. We have sharing in our water atoms, H2O. We have that transfer electrons in our sodium chloride. What this is talking about is that because oxygen is more electronegative, that means it's going to have kind of a partial negative charge. So any of my oxygens are going to have kind of a partial negative charge in a water molecule. Any of my hydrogens, because those are less electronegative, those hydrogens are going to have partial positive charges. So it's not really positively charged, but it's going to be more positive than neutral. And as we look at this, well, how would, if sodium has a +1 charge, how might that respond to a water molecule? Well, we know that opposites attract. And so why can an ionic compound get broken up? Well, my sodium +1 here is going to be attracted to my oxygen, which has a negative charge, meaning that that oxygen is going to be able to pull that sodium away. Maybe I can show this better. That sodium is getting pulled away from the chlorine. Same thing, my negative chlorines are going to be attracted to my positive hydrogens, and that's going to split up that sodium and chlorine. Same thing here, this sodium is going to be attracted to that negative oxygen. This chlorine is going to be, negative chlorine is going to be attracted to that partial positive in the hydrogen with that. And that is how we get the splitting of our sodium from our chlorine in order to get that to dissolve. So that kind of goes through it a little bit more for us too. Feel free to pause the video and read through that if you need. All right, so how do electrons impact the properties of bonds? So if we want to consider the electrons in each type of bond and then answer the following question. So which type of bond conducts electricity? If you need to go back to your notes from yesterday where it listed that had the pages with each of those properties, you can. What we discussed yesterday is that metallic bonds are going to conduct electricity as a solid, and that is the only solid that's going to conduct electricity. And then ionic bonds conduct electricity when they are dissolved in water with that. And so discussing a little bit more about electricity, we talked about this a little bit in yesterday's notes, but electricity is a form of energy that results from the existence of charged particles. And what needs to be true about these electrons in order for a substance to conduct electricity? Well, it has to have charged particles, whether we see that as an ion or free electrons. And those need to be free to move or flow in order for electricity to be conducted. And that's why we see, if we have here are my free electrons that are all being shared, this can move throughout in order to conduct electricity. Same thing here with when we had our dissolved sodium chloride.
Excuse the interruption. We're going to have seniors start to head outside to the Panther Stadium for the senior panoramic. Seniors start heading outside to the football field.
All right, and so then we also had those charged particles able to flow when that was dissolved. All right, take a moment, pause the video if you need, and feel free to read through this a little bit more. So how do electrons impact the properties of bonds? Now if we're looking at how they're holding together, so that strength of the bond. If something is held together strong, it will take more or less energy to break those bonds. Well, if I have a strong force holding those together, it's going to take more energy in order to break those bonds apart and to move that from a solid to a liquid. And remember our Coulombic force, that attraction of our charged particles. Hopefully it made sense. That strong Coulombic force, that meant we needed more energy. Now, we're not necessarily talking about the ionization energy, but just how do we get those particles to rearrange? So how is the strength of the bond related to its melting point? Well, if we have a strong bond or a strong force, that means that the melting point should be very high because we need a lot of energy, heat energy, in order for that to melt. If we have a weak bond, that would result in a low melting point because we need less energy in order to break those up. All right, again, feel free to pause on here if you need. So if we want to look at writing a CER, claim evidence reasoning, if I want to say I know that this substance is ionic or covalent, my claim is going to be about what type of bond I think is occurring. My evidence is going to be observations. So what did we see when we tried to melt the object? We're not going to know what these substances are, so we can't talk about their atomic structure. So this is going to be observations from lab when we're testing those different, testing the different things or different properties of our types of bonds. And then our reasoning is going to be relating that to our atomic structure. So feel free to read through that a little bit more, but let's do one together. So a substance that was a white powder was tested. It melted on a hot plate and it did not conduct electricity as a solid. What type of bond is present in this substance? So our evidence is what it is telling us here. So my evidence, I don't know that I can make a claim yet. Let's look at what our evidence tells us. So the substance melted on the hot plate, and the substance does not conduct electricity as a solid. So with those things, we want to consider what might be our type of bond that's happening. For me to say, this substance has what type of bond with that? And let's look at what this evidence has. So if the substance is melting on the hot plate, that means that it has a low melting point because we can melt it at a fairly low temperature. That, when we're looking at what our types of bonds are, what has a low melting point? Well, covalent bonds are the only ones we discussed as having a low melting point. A substance does not conduct electricity as a solid. Well, that could be ionic or covalent. And so as we're looking at these, well, which one is it going to be? The only one that applies to both is that it has to be a covalent bond. So now let's talk about our reasoning. And with your evidence, you should have two pieces of evidence in order to support your claim.
Again, can we have all seniors outside to the Panther Stadium? They're getting lined up for the pitchers. All seniors outside.
Apologies. I did not think announcements would be happening during this. All right. So how can we connect this with our reasoning? Covalent bonds are fairly weak because they are sharing electrons. So they have a low melting point. So there's my supporting of my first piece of evidence. It melted on a hot plate. So melting means melted means it has a low melting point. It didn't take a lot of energy. So fairly weak bonds. And then how can I talk about not conducting electricity? Covalent bonds share their electrons in a set location. So there are no electrons to flow freely and conduct electricity. So conducting electricity to that flow of electrons, connecting strength of your bond to how strong that compound forming is as we are looking at doing a CER. All right, reach out to your teacher with any questions. There should be some practice posted for you.